Hello, ladies and gentlemen. Welcome to Data Talks with Loren. This is a show we talk about emerging trends in the data world to enable people to stay informed. We've been covering the Kusoma series, and in last week's episode, we talked about artificial neural networks. If you managed to get to the end of the episode, of course, you saw a quiz, and the answer to the quiz is... And if you didn't, please go back to the episode, find out what the episode is about and what the quiz was about, and then get to the answer that has been shared on this episode. Today, we are going to focus on decision trees, and I'll let my guest introduce herself, and then we'll dive into the questions.
Hello, my name is Rita Echesa. Mnanijua kama mwalimu wa maths. I am back again. This time we are dealing with decision trees. Yes, Loren.
I love that. So, Rita, let's start by defining decision trees.
So a decision tree is a tree-like structure that represents decisions and consequences of the decisions made.
Okay.
So a decision tree consists of a root node.
Yeah.
We have the initial node.
Yes.
We have leaf nodes.
Yes.
And also branches, thus forming a hierarchical architecture,
Okay.
forming a tree.
All right.
Yes.
All right. So on to the question. We have this table-like format, right? And then the question reads, a decision tree classifier is to be trained to predict the likelihood of a vehicle rolling over during a sharp turn based on input features, being vehicle speed during the turn, mph, angle of the turn in degrees, types of the vehicle. This could be either sedan, an SUV, a pickup truck. Then we also have the weight and the road surface. The conditions are that it's either a dry, wet, or icy surface. And then we have the tire tread and the driver behavior, e.g. the driver could be aggressive or cautious. So the question reads that we calculate information gain of attribute in terms of the vehicle type and the road surface. Then you compare them and comment on which one of these two is suitable for the best split.
So from the question we got, you can see the decision. We have instances of yes and no, 6 instances of yes and 4 instances of no. So we have to first of all calculate the entropy of this decision. So set is equals to x will be 0.6, which is 6 out of the total, which is 10, log base 2, 0.6, minus or negative minus 0.4, 4 out of 10, log base 2, 0.4. So here's the calculation. Instances of yes were 6, instances of no were 4. So you take the instances of yes out of the total, which is 6 out of 10, equivalent to 0.6, log base 2 of the instances of 6 minus instances of no, which is the negative, log base 2 instances of the log. So when you calculate that, you get the entropy of the set is 0.971. So to calculate the information gain, since we've been asked between the road surface and the vehicle type, which one should be the root node? So we need to calculate the information gain for both, and then compare. The highest becomes the root node. So information gain formula is written up here. To calculate the entropy of individual attributes, vehicle type. So vehicle type has SUV, sedan, and pickup. Instances SUV appeared yes was twice. For negative was 2 times also. For sedan, positive was 0, negative was 2. For pickup, positive was 4, negative was 0. To calculate the entropy of SUV, we take the instances of yes over the total, log base 2, instances of yes over the total, minus instances of no over the total, log base 2, instances of no over the total. So when you calculate log base 2 of 2 out of 4, you get it is 1 times 0.5, you get negative 0.5, minus, so also here the output will be negative 0.5. So when you add the two, you're supposed to get positive 1. For the sedan, that where one of the instances was 0, this accrues to 0, and also this other part, log 2 over 2 is also 0. So here will result to 0. So for sedan and pickup, the entropies are 0. However, for SUV, the entropy is 1. So we want to calculate the information gain for the vehicle type. So to calculate the information gain for the vehicle type, we take our entropy, general entropy, which was 0.971, subtract summation of the instances of SUV was 4 out of the total, which is 10, times the entropy of vehicle SUV, which was 1, plus instances of sedan was 2 out of 10, times the entropy, which was 0, plus instances of the pickup, 4 out of 10, times the entropy, which was 0. So when you do the summation, 0.971 minus 0.4. So you should get the entropy here to be 0.571. So this is the information gain. For vehicle type. So here we have calculated the information gain for vehicle type. Now we need to calculate the information gain for the road surface. Using the same formula, you calculate the entropy of each entity in road surface, and then now calculate the information gain. Once you do that, you will find your information gain for the road surface is 0.109. So the information gain for the road surface is 0.1709. So when you compare the two, you'll get that the information gain of the vehicle type is higher than the information gain of the road surface. So we pick a vehicle type. So our root node will be vehicle type. So it will, if we are to draw a tree, it will start at vehicle type, 3 branches, which is the SUV, sedan, then the pickup. From there, now we can deviate further with the tree given the information gain of the other attributes.
So Rita, as we conclude, what are some of the advantages and disadvantages and applicable areas for decision trees?
So one of the advantages of a decision tree is improved classification accuracy.
Okay.
In this, I mean that we only pick the data that has the most information.
Yeah.
The one that least information, we prune it out.
Okay.
And then also, it is easy to interpret the decision tree because the visual, when you get it through that tree, it gives you an easier and simplified way to interpret the decision, how the decision was made.
Okay.
Yes. On to the disadvantages. One of the disadvantages is that if you change one variable in a decision tree, it has a huge impact on the output.
Okay.
Some of the applications of decision tree will be student performance, review, and also the employee recruitment. So in this, given employee details and also students' details, one is able to deduce like if an employee is a potential employee or if they are not to be hired. And also for the student, if the student is going to perform well or if the student is going to perform poorly.
Okay.
Yes.
All right. Thank you so much, Rita, for sharing some of this knowledge. Yes. I hope, guys, you learned a lot from this episode. We'll share a quiz that you can be able to calculate by yourself and then generate an answer, which will be shared in the next episode. So thank you so much for watching and see you in the next episode. Bye.
Kwaheri.